Sliding filament theory is the currently accepted model of the striated muscle contraction. According to this theory, when a skeletal or cardiac muscle cell contracts, thick filament, the myosin, and thin filament, actin, in sarcomere slide past each other, pulling the sac lines at each end of the sarcomere close to one another. Shortening the sarcomere thus the muscle cell, while the group of filaments in the sarcomere remain at a relatively constant length. Myosin is the motor protein that does muscle contraction by pulling on thin filaments, actin, in muscle cell. Each myosin molecule is composed of tail region and head region. In the thick filaments, these tail regions are bundled together, while their heads are sticking out. Thin filaments composed of actin molecules, which have binding sites for the head region of the myosin molecules. Head region of the myosin can also bind within the ATP molecule when it's a low energy state. When the ATP molecule is hydrolyzed to form ADP and phosphate. While releasing energy, the myosin head enters into a high energy state. At this stage, the myosin head binds to the myosin binding site of the actin, forming a cross bridge. Thereafter, the myosin head returns to its low energy state by releasing ADP and phosphate, which slide the thin filament toward the center of the sarcomere, so shortening the sarcomere. When a new molecule of ATP binds to the myosin head, cross bridge is broken. Myosin head detaches from the actin. A new cross bridge cycle begins again. Contraction of muscle requires a many number of repeated cycles of binding and releasing. In each cycle, the myosin head released from the cross bridge. Newly bound ATP is hydrolyzed, which promotes the binding of myosin again to the new actin molecule. This process occurs along the entire length of every microfiber in the muscle cell. Since in the early cycle, the thin filament has moved towards the center of the sarcomere. New binding site for the myosin head region is exposed in the thin filament. The entire process causes the thick and thin filaments in the muscle cell to slide past each other, pulling the sac line at each end of the sarcomere close to one another, shortening the sarcomere. Many myosin heads can be found in one thick filament. Within 1 second, each of these heads can form cross bridges. Ca2 plus some other proteins play a major role in muscle contraction. Myosin can only bind to actin when the binding sites on actin are exposed by the actin action of calcium ion.